Hello and welcome to pH Chemistry. Today's explainer is the giant covalent structure, diamond, graphite, silicon dioxide. By the end of this video, you'll know why these melt at thousands of degrees and why only graphite among them conducts electricity. A giant covalent structure is a huge network of atoms all joined by strong covalent bonds. There are no separate molecules. The whole crystal is one giant network. Examples include diamond, graphite, graphene, and silicon dioxide, which is sand and quartz. Three things. 1. Every atom is bonded by covalent bonds, no small molecules. 2. Melting requires breaking enormous numbers of strong covalent bonds, so melting points are extremely high. And 3. Most giant covalent solids don't conduct, but graphite is an important exception. Common slip. Confusing giant covalent with giant ionic. There are no ions in a giant covalent structure. The bonds are covalent, shared electron pairs, not electrostatic. And there are no separate molecules either. It's one continuous network. Quick example, diamond. Each carbon is bonded to 4 others in a 3D network. It melts above 3,500 degrees, hardest natural material. Silicon dioxide, each silicon is bonded to 4 oxygens, also super high melting. That's giant covalent strength. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE higher revision planner ready to download, plus the mastery workbooks, one for every higher topic, every answer fully worked, every common slip flagged. Simple explanations, serious results. See you next video.